Hey, Math 1. Today we're going to start Chapter 6. Next week will be our first week back in school, so I can't wait to see everybody. Hopefully this first section will go pretty easily for you. Here we go. Let's get started, I guess. Chapter 6 is all about solving a system of equations. And so here we go. Let's see what we got. Before we can solve a system of equations, I think we would like to know, what is a system of equations? So, here's what it is. What is a system of equations? It is two or more equations that share the same variables. Two or more equations that share the same variables. Now, typically, we will mostly see systems that have two equations with two variables. You could have as many equations and as many variables as you want, but typically we will have two equations, two variables. You need as many equations as variables to be able to solve the system. For instance, if I had a system with only one equation and two variables, I wouldn't be able to solve it. You got to have as many equations as you have variables if you're going to solve the system. All right, so I have a couple examples here. What are some solutions to this equation? All right, so this equation has two variables, and solutions to it would be ordered pairs that make it true. That's all we need, some ordered pairs that make this equation true. Well, certainly that's not too difficult, right? Maybe 7 and 3, maybe 1 and 9. How about 11 and -1? That works, right? How about 7.4 and 2.6? All right, obviously I could come up with as many ordered pairs as I want, infinitely many, that make that equation true. And that's why if you only have one equation, but with two variables, you can't solve it. There's infinitely many ordered pairs that make that true. I have a second one here. How about some ordered pairs that make this equation true? I guess 10 and 8 would work, right? Or 5 and 3. Or if we want to get tricky, 0 and -2, right? 0 minus -2 would actually equal 2. There's some ordered pairs that make that true. So this is really our goal. The solution to a system of equations is an ordered pair that makes each equation true at the same time. Our job is to find that ordered pair. How about in these two equations, you guys? I made these really kind of easy on purpose. Can you see the ordered pair that would make both equations true at the same time? It is actually 6 plus 4 is 10, and 6 minus 4 is 2. This is the ordered pair that would be the solution to that system of equations. That ordered pairs makes both equations true at the same time. That is our goal in this chapter. Find that ordered pair that makes both equations true. Now, one more quick thing. Typically, the answer is going to be an ordered pair because typically we are going to deal with equations that have two variables, and typically they're going to be linear equations, though maybe not always. But what if you had, say, 3 equations with 3 variables? Your answer then would not be an ordered pair. Your answer then would actually be what we call an ordered triple. I mean, the bottom line is you need a value for each variable that makes all the equations work at the same time, right? All right, so there are actually 3 different methods that we're going to learn to find that ordered pair that is the solution. And today we're going to do the first one. The first one is the graphing method. Should be something that's not hard for you at all, assuming you're good at graphing. So what you do is, step 1 is you just graph each equation on the same coordinate plane, right? Equations can be graphed by putting the equation into slope, intercept form. That is when the equation looks like y equals mx plus b, right? So once you graph both equations, you're simply going to name the ordered pair where the lines intersect each other. This ordered pair is the solution to the system. And here's why. The ordered pairs that are on the line are the solutions to the equation for that line. I like to always say a line is just a picture of the answers to an equation. That's when you graph an equation, you're really just showing a picture of the answers to the equation. And since the point where the lines intersect is on both lines, then it must be a solution to both equations, right? So if you can find an ordered pair that is on both lines, it is a solution to both equations, and therefore it is the solution to the system of equations. Now, one of the nice things about this chapter is you can check every answer if you want to. You can check your solution by substituting it back into both equations to make sure it works for both of them. And if it does, you have found your solution. Let's do a couple examples. So in this first example, I want to find the solution. This equation is already in slope-intercept form, so I'm going to do that one first, right? The y-intercept is -7, so I would put a dot at -7. The slope is 2, which means I'm going to go up 2, right 1, so up 2, right 1, 1, 2, 1, up 2, 1, up 2, 1, and there is the graph of that one. Those are all the ordered pairs that are solutions to the second equation. The first equation is not in slope-intercept form, so I'm going to put it in slope-intercept form by moving the x to the other side, right? This is a skill that we all have. And then I'm going to divide everything by 2. And I'm going to get y equals negative 5 halves x plus 2. So that line has a y-intercept of 2. Let's put a dot there. It has a slope of negative 5 halves. So negative 5 halves is telling me to go down 5, right 2. So 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. There is that line. And my job is to name where they intersect. They intersect at that ordered pair. So my solution is going to be x equals 2, y equals negative 3. Or as an ordered pair, it would be 2, negative 3. Now, one of the things I'm going to ask you to do on the homework on one problem is to check your answer. So let me show you how to do that. You're going to take your solution and substitute it into both equations. So here it would be 5 times 2 plus 2 times negative 3 equals 4. That would be 10 plus negative 6. And yes, that works. You get 4 equals 4. In this one, you would also substitute it in. You would get negative 3, putting negative 3 in for y, equals 2 times 2 minus 7. That would be negative 3 equals 4 minus 7. And yes, negative 3 equals negative 3. That ordered pair makes both equations true, so it is the correct answer. All right, a couple more quick examples here and we're done. In this second one, I'm going to go ahead and do the first equation. Let's see, I'm going to subtract x from each side, giving me negative 2y equals negative x plus 4. Then I'm going to divide by negative 2, and I'm going to get, let's see, negative 1 over negative 2 would be positive 1/2. 4 over negative 2 would be negative 2. So this one has a y-intercept of negative 2 and a slope of 1/2. I'm going to put the y-intercept at negative 2, go up 1, right 2, up 1, right 2, and, ooh, terrible line. There we go. Then the second one, well, look, it's already in slope-intercept form. It's got a y-intercept of 1. It also has a slope of 1/2, which means up 1, right 2, up 1, right 2. These lines have the same slope. What does that mean about these lines? Well, we all know it means they're parallel, right? And parallel lines do not intersect. So all the points on the red line are solutions to the red equation. All the points on the blue line are solutions to the blue equation. But these lines do not have any points in common. There is no point that is a solution to both equations. So this would be an example of a system that has no solution. All right? And I got one more for you. Ooh, both of these need to be put into slope-intercept form. Well, I'm going to do this one faster because I'm confident you have that skill. So this one, first I would subtract 2x from both sides, giving me that. Then I would divide both sides by 3, and I would get that. Let's go ahead and graph that line. It's got a y-intercept of 4 and a slope of down 2, right 3. Or I could go up 2, left 3. All right, and we'll do the other equation. I would subtract 4x from both sides, then divide everything by 6, let's see, that'd be negative 2/3. And that would be 4. And oh my goodness, look at that. These two equations were actually the same equation. So when I go to graph the red one, it has the exact same points. It's the same equation. It's the same line. What does that mean? Well, right, the solution to the system is any point that both equations have in common. And these guys have lots of points in common. The solution here is actually infinitely, see if I can spell it, infinitely many solutions. Notice, this is what a mistake many people make. The answer is not all solutions, right? This is not the answer because, for instance, this ordered pair right here is not a solution. This ordered pair right here is not a solution. The solutions are all the ordered pairs that are on both lines, which is infinitely many, but not all ordered pairs are solutions. All right, I have one more thing to show you and we're done. It's a quick vocabulary lesson. We have a name for systems of equations based on their number of solutions. All right, there are two names, inconsistent and consistent. An inconsistent system is a linear system that has no solutions, where a consistent system is a linear system that has at least one solution. And there are two types of these, dependent and independent. Dependent has infinitely many solutions, where an independent has just one. So I'm going to want you to be able to name what type of system you have solved. For instance, back here, letter A had one solution. So let's go to a different color. How about cool magenta? All right, so what type of system is this? This is a, do you remember? Let's see, one solution. So it's consistent and it's independent. So this would be a consistent, oh, I spelled it wrong. What a dum-dum. Let's see, there we go. Consistent, independent. All right, this one had no solution, so it is inconsistent. And this one has infinitely many solutions, so it is consistent and dependent. All right, they depend on being the same line, I guess. All right, that's it. I think we are done. Good luck on the homework. I'll see you guys next week.